Yes, linear functions and slope. So we have solved linear equations. Those were equations where x to the first power was the highest power. And you've also seen me graph a linear equation. All linear equations, when graphed, are straight lines. Now, since that's probably the most applicable thing in the world, because straight lines are everywhere. If you think about it, even the edge of something a lot of times is a straight line, or a line could be used to represent it. So early on in school, probably around middle school or junior high, when you start graphing, start looking at graphs, straight lines, one of the first things we talk about is the slope. So there are a couple of ways to think about the slope. So I'm going to draw just an example of a linear function graph. Say this is the graph y equals x. Alright, and the slope is going between any 2 points on the line is going to be the change in y over the change in x. So another way that you may have heard that presented is you can consider that the rise over the what? Run. So if you ever heard rise over run, that means between any 2 points, it doesn't matter which two you pick, if you calculate the slope between any 2 points, you're going to get the same slope every time because it's a straight line. Rise would mean how far up is the other point we're looking at. Run would be how far to the right or left. How far up or down would be the change in y. How far to the right or left would be the change in x. Rise over run. Okay. If we actually have those points, then the way that you can calculate the slope, if you have 2 points, let's say that I had one point that was x sub 1, y sub 1, and one point x sub 2, y sub 2. I'm just naming the points. Then you can get the slope by saying y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Alright, so as long as you remember these negatives here, this minus and this minus, that's part of your formula. So as long as whatever you plug in, you subtract. If you plug in a negative, then that would become a positive. Then you would add. As long as you do that, finding the slope between any 2 points is really easy. Alright, so what I usually do, let's say that I was given 2 points on a line and I want to find the slope. So I'm just going to make up some points. Negative 5, 2, and 8, negative 4. let's say that I had a line that goes through those 2 points, and I want to know what is the slope of that line. And what I usually do first is label the points. That way I can make sure that I plug them in the right place. So this is x sub 1, y sub 1, x sub 2, y sub 2. It doesn't matter which one you make x sub 1 and y sub 1. I usually just make the first one x sub 1 and y sub 1. Alright. And now if I follow this formula up here for the slope, then my slope is equal to y sub 2, that's negative 4, minus y sub 1, that's 2, over x sub 2, that's 8, minus x sub 1, negative 5. So negative 4 minus 2 is negative 6. 8 minus negative 5, or 8 plus 5, is 13. So my slope is negative 6/13. Why don't you try this one? Here's your 2 points on your line. Negative 3, 4, and 2, negative 2. Find the slope. Alright, so I usually label my points. It's just so I can keep everything straight, because a lot of times we may have a different formula that uses these same types of points. So I just label those. Alright, y sub 2 is negative 2, minus y sub 1 is 4, over x sub 2, 2, minus x sub 1, negative 3. Alright, so it's going to be negative 6 over 2 plus 3 is 5. Alright. Now, the variable that we associate with slope, do you remember what it is? M, lowercase m. So for this problem we just worked out, the slope is negative 6/5. So m equals negative 6/5. Alright. The reason we use m is because slope comes from actually not an English word. It comes from a French verb, monter, M-O-N-T-E-R, which means to rise or to ascend. So, if you've ever wondered why we use an M for slope, slope starts with an S, but we use the variable M. That's why. It was, I guess, made popular in French first, so we just went with that letter there. Both of the slopes we've calculated are negative. That doesn't mean they have to be negative. It just so happens that the two that we worked out came out to be negative. Now, slope gives us a general idea of how the graph or how the straight line is acting from left to right. If you have a positive slope, I mean, I don't know exactly what the line would look like, but if it's a positive slope, the slope is the line is rising from left to right. So like, see, it's going up from left to right. If you have a negative slope, again, I don't know exactly what the line looks like, but it's going to be going down from left to right. It's going to be a straight line going down from left to right. If you work out and find the slope and you get 0, if something has a slope of 0, then it'd be kind of like this floor in here. When you're walking across this floor, hopefully you're not walking uphill or downhill, or there'd probably be something wrong with the building. So this floor you can think of as like left to right. And if something has a slope of 0, then it is a line left to right, which is a horizontal line. And then we say we have an undefined slope if we have a vertical line, a line up and down. So like these walls here, we don't really say that the wall has a slope. It's not that it has no slope. It doesn't have a slope of 0, but its slope is so great that it's undefined. Alright, so a vertical line slope is undefined. A horizontal line slope is 0. Positive slope goes up from left to right. Negative slope goes down from left to right. Okay. We have several ways that we can write the slope of a line. One way of writing the slope of a line is in a form called point-slope form of the equation of a line. Point-slope form. The point-slope form actually comes from the formula that we use for the slope. The only difference is we rename a couple of the variables. The way that you would get that, though, if we multiplied both sides of this, think about this like it's an equation, because it is. This formula is an equation. If I multiplied both sides by x of 2 minus x of 1, then that would cancel out. And if I flip this thing around, I could have y sub 2 minus y sub 1 equals m times x sub 2 minus x sub 1. Alright, and the only thing different that we do is instead of writing the y sub 2 and the x sub 2, we just make that a y and make that an x. So the actual formula that we use is y minus y sub 1 equals m times x minus x sub 1. You see, it's the same formula, it's just that the y sub 2 and the x sub 2 are just going to be our x and y. So those two variables, the x and the y, that don't have some subscript number, they're just in the equation. They're always going to be x and y. This is always going to be y. This is always going to be x. The things that we have to plug into this equation or this formula is the y sub 1 and the x sub 1. Alright, this is called the, now pay attention to the name of it, the point slope, because you need a point and you need the slope to write this form of the equation of a line. If you're missing the slope, then you have to somehow figure it out. But let's practice, let's write the point slope form of the equation of a line if I tell you the slope equals 3 and a point that the line goes through is the point -2, 5. So if I want to write the point slope form of the equation of a line that has a slope of 3 and goes through the point -2, 5, then it's going to be, you can label your points. There's your x sub 1 and there's your y sub 1. So it's y minus y sub 1 is 5 equals, the slope is 3, times x minus x sub 1 is -2. Alright, anywhere I have minus a negative, I put plus. So this is y minus 5 equals 3 times x plus 2. Alright, so this right here, that is in point slope form. You don't multiply anything out, you leave it just like that. So if the problem that you're working asks for point slope form, that's how you want to leave it. You need two things to write the equation of a line in point slope form: a point and the slope. Alright, now the next form of the line we're going to go over is going to come from this form. So if you can do this, which is just plugging in numbers, the only thing that you may possibly have to worry about figuring out is the slope if it's not given. And we know how to figure out the slope by the slope formula. Okay? The next formula, or the next form of the equation of a line, is called the slope-intercept form. This is probably the most popular form. And we can get the slope-intercept form of the equation of a line from the point slope form. Alright? The formula for the slope-intercept form of the equation of a line is y equals mx plus b. This is the most popular form because it's in y equals form. If you ever noticed, all the equations that we've graphed in here, graphing calculators, you know, they all have y equals. Y equals, or f of x equals, something like that. And the slope-intercept form is the most popular form because if you write the equation in this form, where you just have a 1y equals, then you have an something times x plus or minus some number, then you can identify the slope and the y-intercept really fast. The y-intercept is the place where the straight line is going to cross the y-axis. The slope tells us the rise over the run. Alright? So for this problem that I just worked out, what if the problem would have said write the equation of a line in point slope and slope-intercept form? The way that you put the point slope into slope-intercept form is multiply out the right side and then make it y equals. So I would have y minus 5 equals 3x plus 6. And then get y by itself, so add 5 to both sides. Y equals 3x plus 11. That is the slope-intercept form of the equation of a line. So, and that's not the only way I could get the slope-intercept form from the slope and a point, but if I'm going to have to know both of these forms of the equation of a line, why not just learn the formula for the first one, so the point slope formula, and then remember, hey, if I make the point slope formula y equals, then that's going to be slope-intercept form. Okay? So let's say I want you to try this one. Let's say the problem says write an equation in point slope form and slope intercept form for the line with a slope equal to 6 that passes through the point to -5. So I want you to give me the point slope form and the slope intercept form. Alright, so I want to write the equation of a line in point slope and slope intercept form. There's x of 1, there's y sub 1. The top formula is for point slope form, so I'm going to do it first. So y minus y sub 1 equals m times x minus x sub 1. So it's y plus 5 equals 6 times x minus 2. So that's point slope form. Alright, now if I want slope intercept form, I'll multiply the 6 on the right side, so I'd have y plus 5 equals 6x minus 12, and then solve for y. So y equals 6x minus 17. Alright. Now, what if I was given this graph here, and I wanted to write the equation in point slope and slope intercept form? Well, you wouldn't really even have to have the graph, would you? All you'd have to have is the 2 points. What are the 2 things we need for point slope form? Point and the slope. So you can use either point as your first point. You just need to figure out the slope. So if I want to know the slope, remember that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if I make this x sub 1 and this y sub 1, and I make this x sub 2 and this y sub 2, then I can find the slope. It's going to be -3 minus 6 over 4 minus -2. Alright, so that's going to be -9 over a positive 6, which can be reduced to -3 over 2. So the slope for this line that's shown here is -3/2. Alright, that does match up with the way that we know a line should be oriented, right? I said that slopes that have negative, that are negative, go down from left to right. And this one does. Alright, so kind of reinforce, hey, we probably got that slope right. Another way to tell, you can choose any 2 points. But for this problem, those points were given. From right here, from 0, 0, look at this. 3 over 2. And it's going downhill. So that's a negative 3/2. So I would always use the slope formula though. But you can just see in the graph itself that 3/2 is going on here, and since it's going downhill, it's negative. Or it's going down, it's negative. Anyway, so now we have the slope. So we have 2 points. All we need is 1 for point slope form. So the formula is y minus y sub 1 equals m times x minus x sub 1. So y minus 6 equals negative 3/2 times x plus 2. That's the equation of a line in point slope form. Now if I wanted slope-intercept form, then all I need to do is make this y equals. So multiply out the right side. It's going to be negative 3/2 x, and then negative 3/2 times a positive 2. That's going to be negative 6/2 or negative 3. So minus 3. Now solve for y. Get y by itself. Plus 6 plus 6. So y equals negative 3/2 x plus 3. Notice we have the slope that we got earlier, the negative 3/2 is right there. What's the y-intercept? Positive 3, right? Look at the graph. Where are we crossing the y-axis? Positive 3. It's not a coincidence. It'll always be like that. Whatever number you have out here, if you're adding, the y-intercept will be the positive. If you're subtracting, the y-intercept will be the negative at that number. Okay. Point slope and slope-intercept forms. Now, if you have the point slope form of the equation of a line, most of the time it's not that useful. But you can always make it y equals to change it into slope-intercept. Slope-intercept form is very useful because it can be used, and you can make a table to get points of a graph. It can be used to just get the slope and the place where we cross the y-axis and do a quick sketch. So but that doesn't mean the point slope form is just totally useless. It is useful. Its main use that I use it for would be to put the equation in slope-intercept form. All right. Now, what if I have this? Graph y equals 1. Or graph x equals 1. I don't see a slope and a y-intercept like I do with the point slope and slope-intercept forms of the equation of a line usually. But to graph y equals 1, go to where y would equal 1, put a point, and then draw a line from left to right. So draw a horizontal line. That's the graph y equals 1. To graph x equals 1, you do the same, except you go to where x is equal to 1, put a point, and you draw a vertical line. That's x equals 1. So y equals is going to be a horizontal line, x equals is going to be a vertical line. All right. Now, let's look at the general form of the equation of a line. The general form is AX plus BY plus C equals 0. So basically what it is it's everything moved to one side of the equation set equal to 0. So here's an example of the general form of the equation of a line. 2x plus 5y minus 3 equals 0. That would be the general equation of a line. Let's see, what if I had the same line here? I had a line earlier. It was y equals something like 2x minus 17. If I want to write this in general form, then all I have to do is move this one y over to the right side. So in general form, that would be 2x minus y minus 17 equals 0. We write the x term, the y term, the constant term equals 0. Alright, what if I had, say, y minus 3 equals 1/3 x, or 1/3 times, sorry, write you a parentheses, x minus 5. So that's the point slope form of the equation of a line. What if I wanted to write that in general form? Alright, I need to multiply out the right side. So y minus 3 equals 1/3 x, and then multiply 1/3 times negative 5, you get negative 5/3. Now move the 3 over. So plus 3, plus 3. So let's change both of these, or let's make sure they're both in thirds. How many thirds is 3? 9, right? 3 times 3 is 9. So to put those two together, negative 5/3 and 9/3 would be a positive 4/3. So that just gives me the slope-intercept form. What if I want the general form though? the first thing I need to do is move this y over. So if I move this y over, I'll have 1/3 x minus y plus 4/3 equals 0. Now how is this different than, the general form usually? Usually with the general form, we don't have any fractions. So if you do have fractions, just multiply your entire equation by the least common denominator. So what's the least common denominator? 3. So multiply the whole thing by 3. That'll get rid of all the fractions. 3 times 1/3 is just 1, right? 3 divided by 3 is 1. So that's 1x. 3 times negative y, negative 3y. 3 times 4/3 is 12/3 or 4. So plus 4 equals 3 times 0 is 0. So this right here, that's the equation of this line here in general form. Again, we usually multiply through by the least common denominator if we have fractions. So you may be wondering, why would you ever want an equation in general form? Why not just have the equation in slope-intercept form? Slope-intercept form, to me, is probably the best form. But if you want to graph an equation in general form, it can be kind of handy, because the way that you graph an equation in general form is by using the x and the y-intercepts. And usually you can find the x and the y-intercepts pretty fast. Let me show you how. You find the x-intercepts, or the x-intercept, by, you want to set y equal to 0 and solve for x. So do you see where y is? That term goes away. So what would I have? 4x minus 6 equals 0. Solve for x. 4x equals 6. So x equals 3/2. So what does that mean? That means if I was graphing this, I may not know what the graph looks like yet, but I do know that at 3/2, which is 1.5, about right here, I have a point on the graph where x is 3/2, right there. That's 1.5. To find the y-intercept, we do just the opposite. We set x equal to 0 and solve for y. So if this term is 0 here, means it goes away. I have negative 3y minus 6 equals 0. So move the 6 over and divide both sides by negative 3. So y equals negative 2. So go to where y is negative 2 and put a point. There's the graph. So we can graph that equation without making a table, just finding the x-intercept and the y-intercept. Alright. So don't use the point slope form to help you graph. Either put the equation in slope-intercept or general form. Those are the two forms. Let me show you how to graph an equation in slope-intercept form really fast. Let's say that I wanted to graph y equals 1/2 x minus 1. Alright, so the way that you can graph this pretty quick, and this is probably the quickest you can graph this type of equation. It's probably the quickest way if I had to guess. You don't even have to make a table. Look at the y-intercept. What's the y-intercept? -1, right? So go to where y equals -1 and put a point. Now, if the slope is positive, which it is, from the point you just wrote, go up 1 and over 2 to the right. So up 1, over 2 to the right. From that point, up 1, over 2 to the right. Now I have 3 points. Draw a line through those 3 points, and there's your graph. Alright, again, here's what I did. If you have y equals, you have slope-intercept form. First, go to the y-intercept. Whatever you're adding or subtracting, go to that number on the y, put a point. Then, look at the slope. If the slope is positive, then you go up ever how many the numerator is, and to the right ever how many the numerator is. Put a point. You can do that. You can keep doing that forever and ever if you want to. Alright. Well, how does it differ, or what's different if the slope is negative? Let's say that I wanted to graph y equals -3/2 plus 1. Sorry, -3/2 x plus 1. So what's the y-intercept? +1. Where is y +1? Right here. The way it's different, if it's negative, you go down ever how many the numerator is, and over to the right ever how many the denominator is. So from here, go down 3, and then over 2 to the right, because it's -3/2. From that point, down 3, over 2 to the right. Alright, connect the dots, and you have your graph. So if it's a positive slope, you go up and to the right. If it's a negative slope, you go down and to the right.